Hi everybody, welcome back to another MyTutor online schools tutorial. Today we're doing GCSE Maths and we're looking at iteration and theoretical probability. Don't worry if you don't know what that means, you will do by the end. This session is 1 hour long, so we'll finish at 3 p.m. This is me, Molly, who's leading the session. You've probably seen me before if you've come to these tutorials before, but I'm just finishing my second year studying computer science and maths at Bath, and I've done a lot of lessons with MyTutor, so hopefully I'm experienced. So throughout this session, whilst I'm explaining this actually, we do a Kahoot at the beginning. Oh, excuse me, hay fever season. We'll do a Kahoot at the beginning, and this is quite a long one because there's 2 topics. So I'm gonna, at the beginning, like whiz through it really, really quickly. So you can start joining that now on the Kahoot app or go to kahoot.it. So throughout this session, make really good use of the chat and the Q&A functions, so that you can like tell me your answers throughout, ask me any questions, or tell me to speed up or slow down or go back to your question, whatever it is, just so that it's a bit more interactive, and I know where everybody's at, and all of that. So whilst everybody's joining, I'll kind of explain a little about what's happening today. I'm just popping the code on the chat because I know that people can join even whilst we're going. So today we're looking at 2 topics, 2 different topics. We'll just spend half of the lesson focusing on each one. So theoretical probability. I'll explain this properly once we get into it, but theoretical probability just means it's probably the probability that you're familiar with. So what do you kind of expect to happen? For example, the theoretical probability that when you roll a dice, you roll a 1 is a 6th, because there's 1 out of 6 sides of a dice that is a 1. The reason that we refer to that as theoretical probability is because there's also something called experimental probability. And experimental probability is what you actually get when you try it. For example, if I roll the dice 120 times, the theoretical probability tells me that I'll get a 1 a 6th of those times, so 20 times. But maybe I roll the dice and I roll 1s loads and I actually get them 30 times. So the experimental probability there is 25%. Don't worry if that doesn't make sense. That's just letting you know it sounds like a big scary word. It's just what you expect to happen based on the numbers that you have. Someone said it's also called conditional probability. No, that's actually slightly different. Conditional probability is a type of theoretical probability. We'll discuss that when we get into it. So I'm going to go ahead and start this Kahoot now, even though not everybody's joined. Just join us, we're going along, just because there are 20 questions. So the first one on this is about iteration. And what iteration means is where you take something, take a result, put it back into the equation and run that, then take that result and put it back into the equation. And we'll see why and how we do that throughout. Okay, cool. So a lot of people got that one. So xn is the current term, and so xn minus 1 is the previous term. So as I said, this one will be very, very quick. I'm probably going to skip after 10 seconds. It's just to get a general idea at the beginning. So if you haven't been to these before, I always do a Kahoot at the beginning and then the same Kahoot at the end and see if we've improved overall. Okay, cool. Yeah, this is quite a tricky question. These aren't my Kahoots, by the way. I've merged 2 different Kahoots that I found because they basically did what I wanted to cover. So what's xn? I actually said this one before. Yeah, it's the current term in the sequence. So inductive definition. These are some. Again, these will just be guesses probably until we go through in the lesson. Okay, yeah, lots of people knew that. It's how we find terms in a sequence. And we'll see what that means again, as I said, throughout. xn plus 1. We've had a couple of questions like this, so you should all be able to have a stab at what you think this one is. Yeah, brilliant. Almost everybody got that. It's the next term. Yeah, xn is the current, xn minus 1 is the previous, xn plus 1 is the next one. This, again, you might not have seen this kind of notation. So don't worry if you have no idea what's going on. That's fine. Yeah, so what this means is that the sequence tends towards, that's what this arrow means, it means tends towards the limit L. But we'll look at what that actually means soon. Okay, yeah, a lot of people fall with that. So basically what it's saying is that if a sequence tends towards some limit, and what that means is it kind of gets closer to it but never reaches it, then if you take the next term in the sequence, that also just tends towards it. This one's interesting. Some different kind of problems that we have. And we'll see what we can use iteration for. Yeah, cool, it's solving for x. So what this basically means is it's kind of like trial and improvement, because you try some values, take it, put it back in, find it, take, put it back in. And we'll see some examples in a moment of how we solve for x using that. So this is saying, can iteration produce more than one solution? Yeah, it can. It can produce more one solution, especially if you start from different points. So if you think of a graph that crosses the x-axis in 2 points, and we're trying to tend towards one of those points, if we start over here, we'll tend towards this one. If we start over here, we'll tend towards this one. So the same iterative process, depending on your first value. So this one's very similar to the last thing that I was just saying. Yeah, brilliant. Different solutions for x. So if we start in different places or rearrange the formula differently, we'll just get different solutions to it. Okay, now we're doing probability. So take off your iteration heads and put on your probability heads. Yeah, there were 2 correct answers here. So the people that put 2/3, the reason is because it said less than 4, not less than or equal to. So we're just looking for the numbers 1, 2, or 3. So well done if you put either of those. So again, we're going to have another probability question. Fantastic, yeah. So if you wake up before it 1 out of 5 days, the other 4 you must not. And that's looking at the fact that all probabilities of like all of the possible outcomes must add up to 1. And we'll look at why that is later. Yeah, brilliant. Hey, that was actually 100%, because both of those solutions were correct. They're the same thing. They're the same fraction. Typo here. This is supposed to say white. Yeah, brilliant. And well done to this person who managed to simplify it as well. And they're both correct answers, but simplifying it is always good. Not many more questions to go now. Brilliant, 100% on that one. Again, this is the thing that all the possible probabilities must add up to 1. They were all correct on this one. I would say the most correct answer on here is probably 0. So actually the one that the most people said. And the reason is because we always express a probability as a number or a fraction between 0 and 1. So what is the probability in possible? Just sounds a bit weird. So we say it has a 0. Excuse me, probability. Okay, what about this one? Interesting. Yeah. So the reason that this is the third is that there's 3 of them and it's equal. Like I said, I'll explain them properly at the end. This is very similar to the one above 6. Yeah, perfect. All of the answers were right for that one. The most correct again is 1. 2 more questions left. I don't know why the numbers 38 and 40 are at the bottom of this picture. I think you can ignore them. Perfect. I think this is the last question. Brilliant, because there's only one multiple of 4. Perfect. So that quiz was actually, we're going to be doing questions a lot harder than them, but it's quite, I don't want to put questions that take too long to calculate in the quiz because I don't want to waste too much time doing the quiz, but it's a good way to just check your understanding. Brilliant, well done to all of these people. And let's just have a quick look and note down what the percentage was. 50%. That's really good for a first kind of go at some that we haven't actually covered yet. So like I said, we'll be doing that again at the end. And let's jump straight into, cool, let's just jump straight into the lesson today. So I think we'll start off by looking at iteration. So that's what we're going to look at. So I think the best way and the easiest way for me to do this is just to do it by going through some questions, because it's a very hard thing to just explain straight off the bat. So if I can explain it through a process, then that's a lot easier. So I'm not even going to give you that flow chart. We don't need to look at that. So here, we'll have a look at this. Okay. It says use the iteration machine. We'll just imagine that this says use iteration to find the solution of x cubed minus x squared minus 4x minus 9 equals 0. And by these solutions, that should actually say a solution because a cubic is going to have up to 3 solutions. So this question's a bit odd, but here it actually tells us what to start with. So we know. So the way that we do these is, it seems a bit odd to start with, but it will make sense the more that we do it. So we're going to rearrange this so that we have just one x on one side. So just x equals something else in terms of x. So the way that I'm going to do it, and if you remember in the quiz, it talked about having different methods of rearranging things, and it gave you different solutions. So the way that I'm going to do it is, so we start with this. I'm going to move everything to the right-hand side apart from x cubed. So x cubed equals x squared plus 4x plus 9. So all I've done is I've just added x squared 4x, and 9 to 0 on the right-hand side. And then I'll cube root everything. So we've got x equals the cube root of x squared plus 4x plus 9. And now what we do is we call this xn plus 1, and all of these are our xn's. So what we're going to do is start with putting in xn. So x naught is the first term. We put that in here. We put 3 in all of these here, and we're going to get out another number. And then we're going to take that number and put it into here. So let me show you what I mean, because at the moment it seems like I'm speaking a load of rubbish probably. So if you've got your calculators with you, if not, maybe quickly grab them, because this is a really good thing to learn how to do on your calculator, is we're going to kind of put this in a really cool way where we can just hit equals loads of times and get the answer. So on our online calculator, the first thing that we're going to do is going to press 3 equals. And the reason is because 3 is our starting number. So by pressing 3 equals, 3 gets stored in the answer. So this little A and S here, answer, this stores the previous result that you had. So what we can now write is we're going to write this, but instead of xn, we'll write answer. So we're going to write, oh gosh, I don't know if there is a cube root on here. Let's see if there's a better one, because I really do want to be able to actually show you this. Oh no. I mean, whilst I'm doing this, you can all make sure that you have your oh, there's one on Desmos. Desmos saves the day once again. Desmos is what I use for the graphing. So we do 3 equals, and that stores that in answer. And then we do the cube root of this thing. So whatever the answer is squared plus 4 times the answer plus 9. So whatever the answer is squared, and it's telling us what it is currently, plus 4 times the answer was plus 9. And then what this does is we can hit this, and this has done it for the first one. So look, this is our first iteration, gives us 3.107232506. And then if we just hit enter again, you see how it does the same thing, but it now puts our new answer back into the calculation. And this is what iteration is. You do the same thing, the same calculation, you get out a number, you put that number into the calculation. You get out a number, you put that number into the calculation. And you see we can do this again and again. And we're going to do this because we want it to 2 decimal places. We're going to keep doing this until we have 2 answers with the same 2 DP. So you see here, this would be 3.18. This is 3.14, 3.16. This one's also 3.16. So we know that our solution must start 3.16. Someone said, will this come up on a non-calculator test? I would highly doubt it, because normally if you could solve it using iteration, if you could solve it without a calculator, you'd be able to do it without using iteration. Like, we generally use iteration when we have no algebraic method of finding it. So hopefully that makes some sort of sense. And the good thing is we can just hit enter a load of times. And look, now the answer isn't changing. So we've actually got it now to 8 decimal places. Just by kind of hitting equals loads and loads of times. Because when you put it in again, it doesn't come out. And you can test this. You can put this x equals 3.1636, etc. into this equation, and you'll see that it equals 0, or very, very close to 0, because obviously the number itself will be infinitely recurring. So hopefully that makes sense. We'll do it with another one. We'll do a few more examples. But it's actually, yeah, not too, so for example, so this, look here, I'll put in the marks as well. This is a 5-mark question, and it's really not too difficult at all. So let's have a look. We want to use iterative methods to find a solution to that. So what we do, we rearrange it in some way that it just says x equals something. So we could either rearrange this so that we've got the 2x by itself and then divided by 2, or we could get the x cubed by itself and cube root it. Like either of those works, it really, really doesn't matter. So let's just do, just because it's easy to spot, we can move that x cubed to the other side. So all I've done there is I've just added x cubed to both sides, and then I've swapped around the way that I've written it. And then we'll cube root. Cube root of 2x plus 1. And then, as I said, we call these xn and this one xn plus 1. Because all that means is that the term after is calculated by doing this calculation. And then the next term after is calculated by doing that calculation again, and so on. Someone said, do you have to rearrange it? Yeah, because you need to get it in this form, x equals something. Because you need x in terms of the other x's to be able to like work out what the value is. If you don't rearrange it, there's no kind of iterative method that you can actually do. So let's have a go at this one. So all we've done is this really simple rearranging, just making it x equals something. Then we want to start with 0.5, and it's got to be correct to 2 decimal places. So now we do 0.5 equals, so now that's stored as answer in our calculator. And then that's why we do that at the beginning. And then we put in this, the cube root of 2x plus 1. So the cube root of 2 times that answer plus 1. Hit enter. There we go. And hit enter again and again. And wait until, so this to 2 decimal places was 1.59. This is 1.61. This is 1.62. That one's also 1.62. And we'll be able to tell if we go again and again. There you go. There's our final answer. So this rounds to 1.62. So the answer for this one is x equals 1.62 to 2 decimal places. Is this making sense? Let me know in the chat. Okay, cool. Yay. That's good. Because this can be a really difficult one to kind of explain and also to grasp, because it's a weird, I don't know, it's quite a new, strange way of thinking about things. Okay, so I'll give you one to have a go at yourself. This is all trial and improvement, which is a similar method, but yeah, okay, so we can do some stuff like this. So this is a different type of question. Actually, we'll come back to this. I'll do one more like the one previously. And then, I'll just do this one. Do one more like the one previously, and then, oh, that's decimal search method. Don't want to do any of these. I'll just come up with one. And then we'll move on to the ones that are more like sequences. So let's say we have an equation, x cubed minus 2x squared plus 3x minus 11 equals 0. So the question would say, use an iterative process to find a solution to the equation to 2dp. So give this one a go. I'll give you a couple of minutes. Try rearranging it yourself and then try finding the solution and see what you get. I'm not going to be able to work it out because I need to use the calculator on here. So I won't be able to tell you if you're right or not. I can tell you if you're right in your rearrangement, but oh yeah, someone's asked what's the x naught value. Smart. Didn't actually give you one. let's say you've got to start at, gosh, because sometimes if this isn't their value, try starting at 1 and see. Because I've come up with this, I have no idea if that's actually going to work, so we'll just hope so. Yeah, someone said, do we press enter till the answer stays the same? Yeah. I mean, you can either press, sometimes they'll want you to show you're working a bit more, so you might have to write x0 equals this, x0 equals 1, x0 equals this, x1 equals this, x2 equals this. That's why they only say to 2dp. But to check your answer, just hit enter till it stays the same, and then you'll be sure. Okay, a couple of people have said, right, someone said, how do we notice in the exam if it's asking us for the iterative method? So most of the time they'll actually use those words. They'll say use an iterative method or use iteration. If not, if you ever see x0 or xn or x1, that's what you're looking for. Or if you see a question like the style that we've seen today, hopefully you'll kind of remember this, know that that's what you should do. A couple of people have also said that their calculators won't iterate. Make sure you're definitely putting it in terms of answer. If not, maybe for now, just try using this online calculator here. I'll put the link to this in here because I think it's super useful. But yeah, just give it a go, or maybe like look at your instruction manual or Google for your specific calculator, because okay, a couple of people have got some different solutions. And as I said, I'm not sure, I don't know if this will work, because sometimes if you choose a value too far off, it just kind of extends out rather than actually focusing on a value. So that's the danger of me making up questions. So, but I can definitely tell you how to rearrange. Let's again go for the cube root one. So we rearrange so that we say that x cubed equals 2x squared minus 3x plus 11. So xn plus 1 is the cube root of 2xn squared minus 3xn plus 11. And now we can pop that in. Okay, I've got 3 different solutions from people. Maybe they rearranged it differently. Maybe I've done a peculiar one that doesn't quite work. So we'll put in that first value, just so that that's saved in the answer. And then we do cube root of, right, cube root of 2 lots of the answer squared minus 3 lots of the answer plus 11. And you've got to make sure that all of this is in the, no, not that. Oh, come on. This should all be in the, under the cube root. Let's try that again. Cube root of 2 answer squared minus 3 times the answer plus 11. That's better. You see how it's really important that all of this goes over. So we do that, do it again. Okay, no, this does seem to be kind of going to one. Yeah, that seems to go to one value. So I ended up with 2.53, which somebody else did get. I think it was Kessia who got that. So Kessia got that, fantastic. And Emma just got that as well, which is fantastic. Other people, if you got different values, you might have just rearranged it differently, or perhaps put it into the calculator a bit strangely. But no, this does give you an answer here of 2.53. So well done. those of you who got that. Now let's have a quick look at questions more like this. Oh, there is a question like this about the iterative formula. So sometimes I think the most confusing thing about these can be the notation. Oh gosh. Interesting. I'm not sure that I can make a new page on the. Oh, there's a way. There's definitely a shortcut, isn't there? Bear with. Sorry, the MyTutor space has changed slightly, so there's definitely a way to get a new page. Is it just by pressing an arrow? It is, okay. Computer science student. So questions like this. The notation can be the most confusing bit, and that's what I remember really struggling with. But you've just got to remember from that Kahoot at the beginning that n+1 means the next term, and n just means the current term. So if u1 is equal to 4, we want to find u2 and u3. So all we do is we just plug u1 equals 4 into here, and we'll get the next term, so u2. So what we write out is we say u2 equals, well, we can even write it like this, u1 squared minus 8u1 plus 17, and plug that in. 4 squared minus 8 times 4 plus 17, which we can then work out. So that's 16 minus 32 plus 17. One. So the first term is 4, the next term is 1. Okay, what about u3? Cassie's already got it. Well, I'm not sure if it's right. I haven't done it myself yet, but yeah, that's correct. So what do you think u3 will be? Brilliant. A couple of people have already got it. So this is also iteration because we're taking the answer that we get and plugging it back in to get the next one. So it's the same thing. It's just an equation that we were like writing before to find a solution. So now we do the same thing, but this time u3 is u2 squared minus 8 u2 plus 17. So it's 1 squared. So we're taking the answer to u2. So it's 1 squared minus 8 times 1 plus 17, which will give us 10. Yeah, so perfect. So these really aren't that tricky once you understand what the notation means, and don't be overwhelmed by all the n+1s and stuff like that. So to make sure that I have time, because I want to do the quiz again in about 10 minutes or so, I'll move on to probability. So hopefully that all of that iteration makes sense. You all seem to smash the questions and understand them, which is really good. So let's talk about probability. So like I said at the beginning, theoretical probability is a horrible, scary word that just means the probability that you would expect to get. So in an ideal world where if there's a 50% chance of something happening, it really does happen 50% of the time and so on, then what would it be? What would it work out as? So for example, we could have a question saying, it will either say what's the probability or what is the theoretical probability that I get heads 3 times in a row when I flip a coin. So does anybody have any ideas for what this is? A couple of people have got the right answer. Some other people are having some good guesses as well, which I understand where they're coming from with them. So what we do here is we can start to draw out a bit of a probability tree. Key thing with these is that you don't always need to draw the whole thing. So here's what I would do for this one. We always start from the beginning point and think, right, what are my options? I either get heads or I get tails. And what are the probabilities of those? Well, I've got a probability of, well, let's do it as fractions, a half for each. That's one bit that everybody did work out. Now, we only actually care about following this branch right now because we're just thinking about flipping heads 3 times in a row. So once I've flipped heads, what can I do? I could either flip heads again, or I could flip heads then tails. Each has a probability of a half. And then again, when I flip heads again, I can get heads or tails, and each has a probability of a half. And what you do on these probability trees is you trace the route that you want. So what we're looking at is heads, heads, heads. And you see what the values are, and you multiply them. So a half times a half times a half gives us an 1/8, which a couple of you did get. So the key thing to note here is that when we have basically and is multiplication. So this happening and this happening, you multiply the probabilities together. If you want something or something else happening, you add the probabilities together. For example, let's think about, let's say, there is a fair chance that it will rain tomorrow. There is also a, let's say, a 1/5 chance that, so I'm trying to think of something independent, and I'll explain what those mean in a moment. Let's say there is also a 1/5 chance that, let's go for that example that was in the thing, that I wake up before my alarm. What is the so we'll have 2 questions. A, what's the probability that they both happen? So it's, I wake up before my alarm and it's raining. What's the probability that only one happens? So what we can do here, because these are independent probabilities. So independent probabilities are probabilities that do not rely on each other at all. So they don't affect each other. So whether or not it's raining does not affect whether or not I wake up before my alarm. I suppose you could say in the real world that, you know, it could be the rain could wake me up or something, but you've got to kind of, if they tell you that they're independent, just go with it. We often in probability really strip things back and oversimplify things. Whereas dependent probability, I think the best way to think about it is drawing counters from a bag. So if you draw a counter from a bag, replace it and draw another one, that's independent probability. Because it doesn't matter what you picked the first time, the second one is still completely random. Dependent probability is if we pick a counter from a bag, leave it on the side, and then pick another counter from the bag. That's dependent because it matters what the first one you picked was, because say we picked a blue, there are now fewer blue counters in the bag. So that's what dependent probability is, and that slightly changes how we draw our probability tree, which we'll see in a moment. So what we do here, let's first of all think about the rain. So let's say rain and not rain. So there's a third chance that it will rain, which will mean that there's 2/3 chance that it doesn't. So this is the idea that all the possible probabilities have to add up to 1. So the reason is because 1 means a 100% chance. And there's always a 100% chance that something is going to happen, right? So for example, flipping a coin. They're both half, which add up to 1, because when you flip a coin, it lands on either heads or tails. When you roll a dice, each probability of each number is a 1/6, which adds up to 1, because there's always, like, a number will be rolled. So that's why they add up to 1. And if there's something that has a 100% chance of happening, then it's a probability of 1. For example, rolling a number less than 7 on a dice. And if something has a 0% chance of happening, so it's never going to happen, for example, rolling a 7 on a 6-sided dice, then it's a probability of 0. And everything else is something in between. Okay, so we've done our third and our 2/3, and then what we do is we say, well, if it rains, I can either wake up before or after my alarm. I'll just put before and not before. Now, before is a fifth, so not before is 4/5, and that's actually the same because it's independent. It doesn't matter what the first branch is, the second branches will be the same. And then to work out these probabilities, we just go along the branches. So what's the probability that they both happen? What's the probability that they both, as I wrote? Well, what's the probability that it does rain and I do wake up before? We see that we have a third times a fifth. So it's 1/15. There's a 1 in 15 chance that both of those happen. And then, yeah, loads of people got that. Fantastic. Now, this second question is a little bit harder, but still doable. So what's the probability that only one happens? So we've got two potential outcomes there. So either it rains, but I don't wake up before, which is a third times 4/5, or it doesn't rain, but I do wake up before, which is 2/3 times 1/5. So 1/3 times 4/5 gives us 4/15, and 2/3 times 1/5 gives us 3/15. So sorry, 2/15. I had instead of multiplying. So now what we do is, you know how I said that and something else happening was multiplying? Well, something or something else happening is adding. So it raining, but me not waking up before the alarm is 4/15, or it doesn't rain, but I do wake up before the alarm, 2/15. Add them together, 6/15, which we can simplify. It's always best to simplify probabilities at the very final stage. We can simplify this by dividing both the top and the bottom by 3 and getting 2/5. So there's 2/5 or a 40% chance that only one of those things will happen. So hopefully that makes sense. And all of these probabilities will add up to 1. So our 1/15, 4/15, 2/15, without even multiplying, we know that this is going to be 8/15 because they all have to add up to 1 because something's going to happen. Somebody's asked, do you have to simplify it or can you leave it as it is? That's a good question. Normally, if you have to simplify it, they'll tell you, but it's normally best to. But I don't think you'd be docked marks. So just pay attention to the question and what they're actually asking you for. So we'll do the quiz again in a moment, but let's just have a quick look. There's one question that I want to do here. So this is like a final kind of challenge question on probability before we do the quiz. So I hate when they mark questions like this is very hard. Like, tell me afterwards that it's very hard, but don't put me off from the beginning. So there are X balls in a bag, which, you know, already should probably strike fear through you. So X balls in a bag, 8 of them are blue, 3 are green, and the rest are orange and pink. We don't know about the numbers there. So Jake takes 2 balls from the bag without replacing them. So this is dependent probability. And the probability that he takes a blue ball and then a green ball is 1/10. So we want to find out the total number of balls in this bag, this X. So to make sure that we get onto the quiz, I'll be going fairly quickly, but this will be on YouTube. So go back, play it slower, watch it again, give it a go yourself. So we're going to start off. So he takes two balls. So we'll start off with our first chain, where he can either draw a blue, a green, or an orange/pink. So the probability that he draws a blue ball is 8 out of X, because there are 8 blue balls and there are X total balls. Now we actually don't need to fill in the rest because we don't care about if he draws a green or an orange or a pink ball first, because that's not the bit of information that we have. We just have information about a blue then a green. So after he draws a blue, he can then either draw another blue, a green, or an orange/pink. So we only care about this line here, where he draws a blue, then a green. So the probability that he draws a green ball is going to be, well, there are still 3 green balls in there because we didn't take one out. But now there are actually x minus 1 balls in there because we've taken a blue ball out. So there's 1 fewer balls than there were before. So there's 3 green balls and x minus 1 actual balls in there. And now what we do is we look at what that probability is. It's 8 over x times 3 over x minus 1. And this gives us 24 over x minus 1. And we know that that is equal to a 10th. That's what the question has told us, that this number, this probability here is a 10th. And now look, this probability question has suddenly become an algebraic equation to solve. Now, I'm not going to go through this now because it's algebra rather than probability. So maybe give it a go and see what you get from it. This is on the Maths Made Easy website, so you can check your answer. The answers are available on there. If you want to go to the link for it, it's here. But as I said, I don't want to spend too much time doing something that's not actually the probability. But does it make sense how we formed this equation? Because that's the main bit that I wanted to go over. Just let me know in the chat whether it made sense or you want me to re-explain. Okay, cool. The people who did reply said that it made sense, so I'm hoping. Someone's made a good point, by the way. I'll do that once people are. Okay, cool. I think people get that. I'd really encourage you to go and have a go and see if you can then solve this. It's still some good practice. So let's redo the Kahoot. And we'll see what people get here. Okay, play, teach. Okay, so whilst you're joining, someone's just said on the Q&A, could you change the Kahoot at the beginning and the end because you can still remember some answers? I was actually thinking of this the other day. I was thinking that could be a problem. I can definitely give it a go. I'm not sure if I'll have time to do another one for the one tomorrow. But for when I plan my lessons next week, I'll try to do that, to make a different quiz for the beginning and the end. And I'm going to make them a little bit shorter as well. It takes a while for like me to make them myself, which is why I've been finding them. But I'll give it a go for next week because if it helps a lot, I don't mind doing it at all. So let's we'll give that a go next week, doing a different one. And we can still see, I'll make them the same level of difficulty and we'll see if we can still see if the percentage increased. But yeah, maybe it's increasing because people remember them. So that's a good point, and thank you for raising that because that was something that I was thinking myself. Okay. So I'll pop the game pin in here. And I'll get it started just because I know that this is a long one, but you can join us as we're going, I think. So first 10 questions about iteration. Again, I'll whiz through it because I think people like these ones don't actually take calculations, so you should be able to get through it quite quickly. Yeah, brilliant. The previous term. So we have xn is the current one, and then either side xn minus 1, xn plus 1. These all read quite similarly, so yeah, give it a good check. Yeah, I think the wording, I don't think you're that wrong if you put red. I think by last term they meant the final term. So this was horrible wording. So I kind of think that if you put red, you're correct and you know what you're on about. Maybe this is why I should make my own. What's xn? Yay, brilliant. The current term. So the first term, if I ever put that, we always call that x naught. But yeah, it's the current term that we're working with. Okay, what's the inductive definition used to? And all that means is, you know, in the first one when it said like the iteration machine, induction means the same thing really as iteration. Just kind of going along and finding it. Yeah, excellent. Find terms in a sequence. So we find the term and the next term and the next term. So what's xn plus 1? I realize actually the one about limits is coming up that I didn't actually talk about. So maybe we'll just see if you did remember it from last time. Excellent. So this one, I kind of said all I actually needed to say about this at the beginning because this was more about iteration than an actual sequence. So don't worry too much about this one if you don't get this. Yeah, fantastic. This one is again about sequences and limits. So I'll skip it quite quickly and just see if you remember what I said last time. Yeah, excellent. It also tends towards the limit. I guess we can think about this actually in terms of when we were doing our questions. We say that those sequences with when we were hitting equals, they all tend towards that solution. So if that tends towards that solution, then the next term along also must tend towards that solution. So actually, I guess you do kind of know what that means. We just call that the limit because it's what it becomes. Brilliant. Perfect. So can iteration produce more than one solution? Yay, yes it can. As we've seen, if you start with a different one or rearrange it differently, then it can work. So this I pretty much just said. Yeah, excellent. So hopefully you can see, we normally rearranged it to have it the cube root of something. You could also rearrange it in a different way to get a different x as the x equals. Right, probability questions. I think these are fairly easy ones. You don't actually really need any probability trees for these. Like I said, I'm always aware of how much time the quiz actually takes up. So I didn't want it to, I didn't want to make ones where you had to do too much calculation so that we can do it fairly quickly. Perfect. Yeah, both of those solutions there are correct. The reason is because probability of a number less than 4 is just 1, 2, or 3, which is half of the numbers or 3 of the numbers out of 6. Same difference. Okay. Excellent. So this one is that the probabilities have to add up to be 1. So if he's got a 1/5 chance of waking up before his alarm goes off, he must have a 4/5 chance of waking up afterwards because one of those two things has to happen. So what about here? Classic. Bags of different coloured counters or balls are such common probability questions. You'll get so sick of seeing them. Brilliant. Yeah, so both of these are the same answer. So the reason that the green and the red one are wrong are because they're expressed as ratios, which we didn't what we wanted, just the probability. And this actually implies that it would then be 6 out of 16. This implies that they're, I don't know, yeah, you can't really write them like this. But yeah, these are both correct. The 3/5 was just a simplified version. Yeah, brilliant. Both of these answers are right. The 2/5 is just the simplified one. So a few more of you actually simplified at that time, which is excellent. So the reason is because if 15 are white, then 10 are not white. So the probability is 10 out of 25. Or the simplified version, 2 out of 5. I think this got we got 100% on this one last time. So let's see if we can do that again. Ah, almost. So the reason is because traffic light can only be these 3 things: green, amber, or red. Red or amber is 7/10. So green has to make it add up to 1, so it has to be the 3/10. Okay. Not many more to go, and we're almost at the end. This one should be super quick answers. Yeah, brilliant. And most people, this is really good because even though all of them are correct here, most people put 0, which I said last time was the answer I would most like you to put, like the best answer, because we say a probability normally in terms of a number between 0 and 1. So that's really fantastic. So what about for this one? Yeah, brilliant. Cool. That was almost all. So yeah, the reason is because if they can either win, draw, or lose, and they're all even, they must be a third each to add up to 1. So winning the next game is one of those thirds. What's the probability here? Again, a nice quick one. Yay, and again, people put the one that I said I most like you to put, which is perfect. And nobody put, yeah, certain, which I'd say is probably the worst one to put here. 100%, we can still express them in terms of percentages and fractions, that's fine. Just 1 is the nicest answer to go for there. 2 more questions, almost done, you can almost go. The spinner, what's the probability? So again, this is theoretical probability, because experimental probability, so, you know, like in practice, maybe it's on a table that leans this way, so it's actually more likely to land on 2 or 3. But in a perfect world, yeah, 3/4. I think those that put 1/4 maybe accidentally saw it as scoring a number that is 1. So careful reading of the question there is key. Final question. Excellent. Yeah, the reason that it's 1 out of 6 is because there's only one number between 1 and 6. So on a die that is a multiple of 4, and that's 4 itself. So that's 1 out of the 6. So let's have a look at the podium. Lilac got 19 out of 20. That's really, really good. Oh yes, top 2 got 20 out of 20. Emma, fantastic. And Smart Dude came first. That's a appropriate name choice. Perfect. So let's see. I mean, some people got full marks on those, which is brilliant because nobody got full marks actually on the first one at the beginning. 58%. Yes, we increased. Excellent. So What you said about the quiz makes a lot of sense. I actually might try tomorrow because I've got another 20 question quiz tomorrow. I might do 10 at the beginning and 10 at the end so that they're different. I'll work on that today. I think that's a really good plan. And we'll see if that works. So thank you very much for coming. Sorry, we ran over by a couple of minutes. I hope everything made sense. Check out the MyTutor schedule for what's coming up later today and tomorrow, and then next week. And also, if you're looking for any one-to-one tutoring, MyTutor offers that on their website, or you can contact their team and they can do team matching for you, which is fab. So yeah, thank you all so much for coming. I will personally see you tomorrow, I believe. So how exciting. Yeah, and well done everybody today. And I'll see you next time. Bye.